So thank you all for coming. We have Marli Rupe from the Clean Water Initiative program and Laura DiPietro from the Agency of Agriculture here to talk about subsurface tile drainage. Bethany is fielding questions online, so if people are listening in, they can just type into the Skype and Bethany will ask questions. Did you want questions at the end, or?
People can definitely ask questions throughout.
Cool. Absolutely. All right. Well, thank you all for coming again.
Hi, folks. We're glad to see a crowd here in the room and also online. I'm Marli Rupe with the Clean Water Initiative program with Vermont DEC, and glad to see so much interest in this subject. Not particularly surprised by that, but glad of it. So I just want to give you a little bit of background about why we're here and what we're going to be discussing. I think as most of you know, Act 64, Vermont's Clean Water Act, which was enacted back in 2015, included a requirement by the Vermont legislature that the agencies of agriculture and the Agency of Natural Resources jointly submit recommendations to the legislature for reducing the nutrient inputs from tile drains, and that changes be made to the Agency of Agriculture's regulations, the required agricultural practices, by January of 2018. As part of that requirement, the agencies submitted an interim report last January that summarized some of the current status of research on tile drains. Did not make any recommendations at that time. And we recently submitted in January a final report to the legislature that did have some recommendations. Some of that is what we're going to be talking about today. But I wanted to let you know that none of this has been done in a vacuum. There was very, very extensive work with both of the agencies, reaching out to an advisory group as well as other partners that gave us a great deal of help in developing this report. This is not an easy topic to handle. There are very strong opinions on it, a lot of strong feelings about what should be done, but both agencies were completely in alignment with one key thing, that any recommendations and decisions be based on science, that we not be doing things based on incomplete research, incomplete data, research that was done in other parts of the country. We wanted to make sure that when we were going to make decisions that have such enormous implications to both farmers and businesses that relate to tile installation, as well as to water quality and the impacts on all of us around the state related to that, that we use the best science for doing that. And I hope by the end of the presentation you will see how we did that and why the recommendations were made such as they are. The Tile Drain Advisory Group that was developed included a broad range of representation. There were obviously folks from state and federal government, but also legislators, technical service providers, people who work directly with farmers to provide advice and information to them. There were farmers on the group also. There were people who install tile drains for a business. There were several representation from academia, from scientists. Who else? Environmental advocates, representatives from the environmental groups. So it was a pretty broad discussion, and we'll be summarizing the results of that as well as how that fed into the tile report. So I'm going to turn it over to Laura DiPietro, who will run through some of the background of this, and we, as I said, we definitely recommend and encourage questions as we're going on throughout this. So.
Great. Thank you, Marli. And if any of you recall, there's and it's probably still posted, a brown bag webinar similar to this for the interim report. So there is one of these that we did probably a year ago at this point. So before I launch in, there's a lot of information about tile drainage that exists out there, and there was also a literature review that was done by the Lake Champlain Basin Program. They supported Stone Environmental to draft a literature review. And that document is also, it's in appendices to this report, so there's a link at the end here if you go to it. Significant amount of information from a lot of scientific resources all pulled together and summarized for the advisory group to be able to utilize as trying to understand the science and information that is available. So I'll be showing some of that information and some of the results and summaries from some of that. So this is the cover of that report, and this is sort of an outline of what was in it. And in addition to the tile drain lit review report, the advisory group that we had put together that Marli had just described, the report summarizing their findings is also in the appendices to this report. So there's sort of 3 reports together, which makes it a little confusing, and there's a lot of redundant information because they're all utilizing the same research articles and whatnot. So when you talk about tile drainage, one of the things, of course, that comes up is why is it installed, and it's because of the agronomic benefits, right? That's the first thing that is worth discussing, which is in terms of, here's just one research. It's a 13-year record, though, which is a nice record. There's not that many long-term records on tile drain research. So here's just a summary of one to give you an understanding of why there is this interest in trying to install tile drainage. Can they see the pointer on the webinar?
Yes.
Okay. So, basically it's no tile drainage, surface runoff drainage, so, ditching or other bedded fields, having just tile, and then having some surface and tile drainage. And you can see this is in bushels per acre, which typically in Vermont we're not doing things in bushels, we do it in tons. But, without tile, there's a significant increase of having drainage in terms of the yield that you will get as a crop. But more than that, and I think that, obviously that's an important aspect, but more than that, I think, is this statement down here, which talks about the variability. So over 13 years, if you're planting a crop and expecting a certain yield, how close you came to that expected yield and the variability in that, it is less risky when you have drainage, right? Because if it's really wet or it's really dry, it can actually accommodate those environmental factors and take that risk out. So you can see, 33% and 46% reduced variability, which is huge. I mean, that's almost half the variability. So you can see why there's an interest in putting tile drainage in agricultural fields. One other thing as far as relating to this, we'll talk about some of the sources of phosphorus, but when we look at Vermont and you look at some of the fields that do have legacy phosphorus in them and figure out how will you remove that legacy phosphorus, the one thing that all scientists seem to agree on that we were working with is that you can chemically treat it, right? You can bind it, but you can also grow it out, essentially. And that's where, there is this argument that is made that by having tile, you're actually able to remove phosphorus from soils that have been there more quickly. When it comes to water quality, though, so that was about, yield agronomic aspects. When it comes to water quality, this is some local Vermont data that we have, and it's not tile drain data, it's surface drain data. But what it shows you is multiple sites here. These are all different, this is Ferrisburg, Franklin County, Paulette, Shelburne, Shoreham, Williston. So these sites are all along the Lake Champlain Basin where we've been doing what we call edge of field monitoring. There's enough acronyms in this diagram here. The edge of field, event mean concentration, and phosphorus. And essentially this chart is showing you total phosphorus, and this one's showing you total dissolved phosphorus. And historically, anyone who was doing agricultural water quality research and the entire USDA system as far as conservation practices was really focused on erosion, right? Since the Dust Bowl, that was the whole focus, because phosphorus has always been known to have a very strong ability to bond to soils or to other organic particles, and then if you physically lost that particle, you lost your phosphorus, right? So it went downstream through erosion. And so a lot of effort for many years, essentially since, probably the last couple of years, all the way back to the Dust Bowl, all the focus was on erosion. And what we're finding now, and it's not just in Vermont, but other places in the country are finding, is that this dissolved portion of phosphorus is actually becoming increasingly more prevalent. And, we don't exactly understand why, which is, again, where current research is all trending at this point, is trying to understand this. But what I want to show you here is, so this is just an overall average of these sites. And you can see 511 micrograms per liter of total phosphorus. So that's the soluble plus the particulate. And then the overall of just the dissolved, so you're filtering out all the particulates when you do it, is 331 micrograms per liter. That's a 65% portion. And granted, you can't go apples for apples because these aren't necessarily maybe all the same samples, but the concept of it's more than half potentially of the loss. And so how do you treat that, right, from surface runoff or from tile drainage? And the root of that comes from, no pun intended, good, I'm glad there's a sense of humor here, is that, how do you physically capture something that can literally slip through whatever you've got, right? It can slip through grass, it can slip through soils, and again, unless it's integrated into microbiology or a plant, it isn't going to be able to be maintained in that profile. There are conservation practices that can certainly assist, and we'll talk about some of that. But this is where increasingly we're seeing this challenge, regardless of surface or subsurface. And so this photo on the right is a picture, obviously, of a worm, but it's also showing you a dye test where people will put dye on the surface to show where macropores or conduits in the soil exist. And with the more increasing silt and clay content you have in a soil, the more likely, and especially with drying and wetting cycles, you'll get cracks. And I know, in Champlain Valley, there are definitely cracks you can stick an entire binder in some years, especially if there's an extended dry period. And so they can be very large, and some of them can go very deep. And when you do have a tile drain system, if you were an earthworm, does anybody know why earthworms come out to the surface when it rains?
So they don't drown?
Essentially, they're able to move and they're looking for oxygen, but more that they can physically move. But you think that they worry about drowning as well. But it's a pathway to be able to move and to get around. So one of the things is that if they can move down into that tile drain, there's oxygen there, right? And so, if you have a very good earthworm population, which is a good thing, right? You want life in your soil of many forms, but earthworms are the ones that can create these large channels. And if you have a tile drain, they can get right to it and create that conduit from the surface all the way down, or a network of conduit. And so breaking up some of those macropores is what they call them. There's obviously finer pathways, which are called micropores. And micropores, if you can imagine, if you had no macropores, it would take a lot longer, right, for any liquid from the top to get to the bottom of the tile. But this is increasingly one of the pathways, and based on my personal opinion, I think for us this is one of our challenges because of the soil types in the Lake Champlain Valley. A lot of them are clays, and even some of the marine clays, because it used to be ocean. So you've got a different chemistry as well. And so trying to manage these, and what we've seen from some of the Ohio research, if any of you have followed some of that they're doing, they've moved to these systems where they're doing less tillage, which is good because you're reducing your surface runoff, right, of physical particles. I was just saying, I went to Pennsylvania the other day, and it was beautiful because there was no-till everywhere, cover crops everywhere. You saw no bare soil, but at the same time, the research coming out of Ohio is showing that some of those no-till systems, you get more intensive macropore development, right? Because you've got a lot more biodiversity, and you're not plowing and breaking up that crack or that wormhole. So it can have a downside, but that's where research is trying to understand what's the better thing. It's like you're trying to fix one problem and you're finding another. And so trying to find the right balance of what is the guidance to give the agricultural community of what the best practices are. So when we went through the scientific review, these are the general areas we covered. I just discussed torrential flow, but also precipitation and climate. And so some of the things are, as far as if you're going to apply manure, the manure isn't going to necessarily move, right? But if it rains, that's going to push anything, right? Soil, manure, into various places. And so the timing of that is really important. And additionally, what they saw too was that the seasonality of it really is important, right? So during the growing season, you see fewer losses. And in the winter months where you don't have the crops actively growing and you have more precipitation events, essentially, whether it's a rain event in the fall or the spring, a melt event, or just cycles of groundwater flow moving, even though the surface may not be. Where in the summer, a lot of times, at least the field work that I've done in Vermont, you'll see complete dry spouts. You might see a tile drain outlet, but there may be nothing coming out of it. To where in the winter, the base flow will move. So those are really important aspects, and managing that and figuring out how to manage around that. And I'll talk about how the RAPs cover some of that. And then the type of systems, which I mentioned, how is tillage a thing we should be telling people to do or not to do? And farmers have questions. It's been heavily promoted. It is a good thing. But are there certain sites where maybe there's different guidance? And the science hasn't gotten us there yet to tell us that. And then the source of the phosphorus, the rate, placement, and timing is, again, if you're using a liquid manure versus a solid manure, the type of manure can have a variation in terms of the accessibility to move, but also what's the rate you're applying it, what's the timing you're applying it, what's the connection to the crop that you're growing. Are you practicing good nutrient management? Because if your crop is going to take up what you put down and you planned for that, then you're going to reduce your risk. And as phosphorus levels in soils go up, what we're also seeing is that, again, historically, phosphorus was always thought to be bound. When you talked about losses of nutrients, if you talked about nitrogen, it was about leaching, right? It moved through the soil profile. Phosphorus was never thought to go anywhere through the soil profile, so there was no concern about tile because it didn't. No one talked about it going down. And now we're seeing that phosphorus does move down into the soil profile, especially that soluble, as I described, the variation that we're starting to see. But so soil test phosphorus, there is this sense that it doesn't move fast, right? So soils can build up in phosphorus, and when they do, what we're seeing is that the increased rate of either surface runoff losses of phosphorus or tile runoff losses of phosphorus go up as well. So it makes sense. So there's a good correlation between increasing soil test phosphorus levels and increasing losses. And so managing those, which is also something in the RAPs. And then depth and spacing is about, if you can think about it in terms of, if you have two tiles that are the same depth, right, but they're farther apart, the amount of water shed above the tile that's drained is reduced to where the closer they are together, they're going to be able to drain more of that shed above it. Does that make sense? I'm checking faces. So the farther apart they are, that behavior happens. And then the deeper that they are, the less connection you're going to have from the surface. So if any nutrient sources are happening at the surface or any buildup of nutrient sources are happening at the surface, they're going to be less connected. Again, macropores throw a whole another wrench in that, but there's that disconnect of distance. However, what's confusing when you start to read some of this, if you're looking through it, if you get deeper, you're getting closer into the water table, right? So your actual flow, which a lot of papers will describe it as discharge, because they're just talking about the water discharge, not the phosphorus discharge, goes up. And so even though you have phosphorus in that, because it will get there, right, but not maybe at the same rate, you may actually lose more phosphorus because you're continually discharging water. So over the course of the water year, there's an increase. So here's kind of a summary of what I described, what we know. Soil is more clay, more preferential flow, the spacing of the depth, end depth, and the variations there, and the increase of the discharge. So by having drainage, you increase discharge, meaning water volume discharge, by 10 to 25%, which makes sense. You know that you're draining the soil. That's the purpose of what the tile is there for. And then surface inlets is another item. If any of you are familiar with it, they're upright riser pipes. They were designed in many instances to try and drain areas, low spots in fields, and they can be a direct conduit to the tile. Typically, they're plumbed to be connected to the tile. And so, managing around those, if those exist, and, think about your house. Everybody has a clean out, right? Everybody's got drainage around their basement, I hope. So you've got to have a clean out, right? Your gutter may somehow disconnect, or get leaves in there, or debris, or rodent, or who knows what, right? And so there's the same concept, is some surface port where there's a connection there. And so managing those. So next in the report, we walked into the local research that's going on. So one of the biggest things is the source, right? So obviously not too much of the source at the right time, that kind of thing. But the way that farms are managing how source goes down is through a nutrient management plan. And that's all regulated through the regulations of either the RAPs or medium or large farm regulations. And so there's a thing called a phosphorus index in it, and it's basically a risk assessment tool. So you have to run it as part of doing a nutrient management plan, and it looks at how far away is water, Are there any ditches or main surface waters? How big are your buffers? What conservation practices are you doing? What's your cropping methodology? When are you putting any nutrients down? What type of nutrients? The whole gamut. But what it doesn't do now is have something about tile drainage in it. And so University of Vermont is working with NRCS, the Natural Resource Conservation Service, to revise that phosphorus index to integrate tile drainage as a risk factor. So taking all this literature information and putting it in there. And so that process is now in full swing. USDA is going to release a new, so the way USDA works is there's a national standard. So there's a national 590 standard they give everything a number, which is the nutrient management standard universally across the country. And then each state is tailored to the specific state. So like in Vermont, as an example, we have a winter manure spreading ban. New York doesn't have that. So that's different from our 590 standard than New York's 590 standard. So they tailor them based on what's going on locally. And so they're expected, NRCS, to release a new national standard. So the NRCS here is going to take the UVM work and the national standard and revise the entire new 590 standard and release that. So that's ongoing right now. And then research into drainage control structures. So over at Minor Institute, which is just over the lake in Chazy, New York, they're doing research with these structures. So basically, if you can imagine a tile being intercepted by, it looks like a box. These images literally almost exemplify it pretty well. And there's basically these drop gates that you can put in, which you can level how high you want the water table to go. So the idea is with some of this research is that you block off the flow during the time, like right now, right? When you're not growing a crop, it's okay if everything is a little bit wet. And then you open them, obviously, in the growing season. Because, again, most of the losses that you're seeing in the research are in the winter months when you're not growing a crop, which makes sense because it's not being utilized. And it's the wetter time of year. However, one of the things that is always fun with everything is that for every good, there's always an alternative, which is phosphorus can start mobilizing when it's under anaerobic conditions much more quickly than it can if it's under aerobic conditions. So when you back up the water, you mobilize the phosphorus. And whether it's actually leaving the field or not, we know it can move around locally. That's the research that we're trying to figure out is how able are things, if the tile is still blocked, to go essentially laterally out the field. So far the research is showing overall that this seems to work, but more research into it and more site conditions certainly would be helpful to know that it is something that consistently works. And then, again, when it comes to phosphorus, the physical binding of it and taking it out of the soil is the strongest way to get it, so a chemical bond, essentially. And so one of the things we've been looking at, especially the soluble, right, something you can't filter if it's moving through, if you chemically bind it, you're going to be able to grab it. And then what do you do and how do you get the material out is essentially what these removal systems with media are. So there was a site that we put in, and there's a couple of these in the country. We put one in Vermont to look at basically two different materials, so a limestone and drinking water residuals. So at the Champlain Valley Water District, when they filter the water from the lake, they use water treatment residuals, and the filter that they put it through leaves the water treatment residuals, which they're able to scoop up. It's alum, essentially. So they filter through. And so aluminum and phosphorus have a very strong bond. And so if you use this material, what we did was we put it into a concrete basin and filtered it through, and it bound the phosphorus, and then you can remove that material. And so that was very successful. The questions we don't know or have total answers to is how long does it work? We've never tested it. Is it a 10-year practice that if we were to recommend it to farmers that it would work? Some other research that we've had with slag is, and even with septics, if you basically shut them off, they can sort of clean themselves. The biofilm can eat itself away and then become recharged to be reused again. Will that happen in this scenario? We just don't have enough time on the research to know that. But we've moved in that direction. There were really good positive results with the research project, so we want to continue. And we also want to move it to becoming lower. We built that for a research site. You've got to be able to quantify the water. That wasn't applicable to say, okay, everybody go put this out in the field. This is the project that we think you should invest in. And so we need to build more field-based truth in lower cost, lower tech methodologies. Constructed wetlands, there's a lot more work going on nationally about this, and it's more focused on the nitrogen because they're much more effective at managing the nitrogen. Typically, the phosphorus reductions that are coming from constructed wetlands also have some kind of chemical interaction, so like a dosing station or something that is allowing the phosphorus to be removed. Things like charcoal or mulch bedding, things like that, are better with the nitrogen, not the phosphorus. So they can be a combination system, essentially. And then, obviously just monitoring these tiles. One of the things, as we've talked to researchers about helping do research projects, the questions that they have is, well, what's the flow of this thing throughout the year? And how do you monitor if the wettest, toughest part of the year is also where you're going to have your freeze-thaw cycles? How do you get equipment out there? When it's flooding, how do you, these tiles are at the bottom of the water, right, it closes to the water table, and when it's flooded, they're underwater. So you're then treating inflow water versus outflow water. And so trying to understand how the water works within the tile is really critical to being able to implement whatever strategy you want to implement as far as a conservation practice. And so understanding more about these tiles, where they are, how deep they are, what's the average information, can really help us get there. And then looking at surface and subsurface. There's definitely research that shows you that as you implement tile drainage, you reduce phosphorus because you've lowered the amount of surface runoff erosion. Conversely, there's also tile research that shows you with tile, you've also increased tile losses through tile drainage. And all the factors that come into those two scenarios are pretty blended. And the answer is not perfectly clear that by doing tile or not doing tile, you're overall reducing the load of the field. That load is there, right, because it's a legacy issue, or it's the surface application. And so managing those two things is really more critical to understand, in my opinion, than trying to figure out, exactly which is better or worse for loss, because right now it's showing that both have losses, and there's a lot of scenarios. So when we looked at the knowledge gaps, the first thing we wanted to do in that portion of the report was explain what the current regulatory structure was for tile drainage. And so the Clean Water Act regulates agricultural losses throughout the country. Agricultural drainage losses are not directly regulated in that sense. However, there have been court cases more recently that have shown when you don't follow a nutrient management plan, you over-apply and it runs off, there are consequences in terms of the nutrient losses there and being covered under the RCRA regulations in that particular case. So there is a framework in place, but tile drainage, historically was promoted by the U.S. government. And so at this level, it isn't something that is regulated in terms of the outlet unless you go and exceed the standards that are in place for the management. So it's more of a management standard, I guess I would describe. Or you cannot drain a wetland. A lot of things have been put in place to limit future challenges, but certainly a lot of this was installed through the U.S. government and subsidies to promote it. And then, design installation. So if you are looking to install something, you usually grab an instruction manual, right, to figure out how to do it. Right? You all read your instruction manuals, right? So they obviously exist for tile drainage, the best practices for installing tile drainage, but they're looking at it from that crop yield perspective, not from the environmental perspective. And so there isn't information to be able to say, because this is something we really tried to research into and figure out, if there's guidance on doing this better, and the installers want to know, the farmers want to know, let's figure it out. We didn't really see that as information that was available. So that's definitely a knowledge gap. And then management around tile drain systems. There's a lot of conservation practices that are being managed on tile drain systems. So, cover cropping, no-till, we talked about those. Some of the areas around, at the end of, here's an example of a tile drain installer was explaining to us, when he knows that there's some area that becomes a wetland beyond the field, that area nearest, he'll put a hard pipe instead of a perforated pipe, because you can't mess with the hydrology of the wetland, right? So you kind of cut off that connection between the drain land and not draining all the way into something that would lead into a wetland. And so simple little management practices like that could help work with the tile drain system. Just, what is the recommendation for the farmers, because they are seeking this guidance. And then evaluating the impacts of tile and conservation practices. Again, is no-till good or is no-till bad? I think no-till's good. Is cover crop good or bad? Good. It definitely has its benefits, but in certain soils, is it going to create consequences that later we will then be going back on? And if you think from the farmer's perspective, one of the challenges they have is, the federal government gave them phosphorus and told them to put it on their fields, so now they have a phosphorus issue, or told them to put it in the barns. The feed recommendations were much, much higher many years ago, which then that's all on the farms. And the farms were told, take your buffers out. You don't need trees. Straighten your ditches. Improve your drainage. So all of this stuff that the government supported, we are now saying this isn't what we recommend. And so they're standing here looking at us and going, okay, you want us to do something. We want to know that it's going to work, and you're not going to tell us to redo it a number of years later. And in the pace of some of this research and information, those years could literally be 2 years later. We might have a different opinion. So trying to do this with really good thought put into it and not getting too far ahead of ourselves that then we, one, don't utilize funding or resources appropriately, but two, don't create challenges on an actual farm or potentially worsened water quality. So from the literature review that was done by Stone Environmental and all of the research there, the main things that they talked about was the assessment of understanding tile drainage in Vermont. So people don't have to tell us where tile drainage is. And the itemization here is that, understanding that extent, understanding the depth, the spacing, the type of tile. There's clay tiles, there's black lime perforated tiles, there's white, not as many of, but the white hard line tiles. What is out there and where is it? And there's definitely you just threw it in a wet swag or swale. There is, you've done the whole field very systematically and they're evenly spaced apart. There are, in an individual ditch, for instance, an agricultural ditch, there may be many outlets, there may be one outlet of a tile drainage. And so when we're doing research and you look at, okay, well, this is a, 8-acre site, but the next tile line down is a 22-acre site, the type of conservation practice you might put at the end of a tile in those two situations is dramatically different because the volume of water could be dramatically different. And so just understanding this, if we knew, for instance, 70% of the tiles are this type, this depth, this spacing in general, trying to get a one-size-fits-all BMP, best management practice, designed and focused around that would be much more helpful to know what our target is, right? So these are the areas, and they did a separate report where looking at mapping. So trying to figure out if there's methodologies we can look at for mapping. Most of it kind of came down to literally being in the field and walking over it like you're walking with a stroller is the best approach, but obviously it's not a stroller. It's ground-penetrating radar. That's what it looks like. It's like a dog stroller. Obviously not feasible to get all of the things mapped. But there's an in-between there that can help us get information, and that's one of the things we intend to work on. From the advisory group, there's two items here. We looked at feasibility in this one, and they said basically, really focusing on good management practices above the ground is really where the focus is. Educating people on what those are, identifying what they are, and finding out BMPs that you could put in the system. So maintaining the status quo, but looking at surface management and end-of-pipe management as solutions. And then the advisory group looked at, well, okay, so that was the feasibility, like what we do today. And then the next thing they said, well, what about water quality? What's the most impactful for water quality? And they said, again, that source, managing that source at the surface, so educating people on doing nutrient management plans, doing site risk assessments, so that phosphorus index and incorporating that tile drainage as an index, and then looking at treatment technologies and doing much more research there. And here's just a ranking from top to bottom so you can sort of see that way of the advisory group's preference. And so you can see down at the end, doing the status quo, having a moratorium or a complete ban didn't seem okay to anybody. And remember, Marli described it's a very diverse group of people. But everyone thought there's some science and innovation that we really do need to identify and work with. So our recommendations as an agency is to focus on the education, work towards creating opportunities to give people workshops to help them before they install tile to understand this, And then every workshop and thing we do, integrating it, so that way we talk about tile more and more. And then in the RAPs themselves, there's a couple things. So fields that have more than 20 parts per million of phosphorus in them, which on the UVM scale is excessive for nutrient needs on a crop. So if you're at that level, you have to have a reduction strategy. Are you going to put your manure applications in half? Are you going to change your farm potentially, or in terms of land or cows or other things, to accommodate a lowering of nutrient on the farm? And then those riser inlets that I described, there's now buffer requirements around them for both keeping grass, but also keeping manure away from those inlets, as well as there's increased buffer requirements along surface waters and along ditches, which currently that was something that was never a regulatory requirement. And then on floodplain fields, any of these fields that are in these areas that are frequently flooded, they cannot put manure down past the fall. So past October 15th, there should be no manure, and it's a later start date to start putting manure out on these fields, which is later in April. And so trying to get those shoulder seasons, as I described, those winter months where the risk is higher, to keep less of that nutrient there and have it put on earlier so that it can be integrated with the biology of the system before the biology goes to hibernate or slow down significantly. And then the P-index we talked about already. We have sent out a note to a group. We created a farmer work group, which is going to help us with the tile drain work, but also additional stuff in the RAPs that we have to work on. But this includes, there's 3 farmer watershed groups. There's one in the Connecticut River, there's one in the Addison County area, and one in the Franklin County area. Rural Vermont, the Vermont Dairy Producers Alliance, NOFA Vermont, and Farm Bureau. So we sent all of those organizations an invite to come and participate and work with us so that we can try and get to some of the answers. And some of the things we need to do is figure out the next steps for research. So there's research going on. There's funding available for doing research from USDA, from state government. Other private organizations are willing to donate or have grants to do research. And it's time we all sit together and figure out what are we going to do. What are the top questions that need answering about tile drainage, and what is the best effective way to do a research project to get those answers? And so that's the next step. We're going to meet before the end of this month to try and get at that, so that if it's UVM or Minor Institute or Agency of Ag and DEC, we're all doing the same mission plan for researching tile. And then looking at trying to do some of this evaluation and mapping of tile drainage. So we will continue on the report that was provided by Stone Environmental on doing this work and try and move along with the right things based on the input from that advisory group. That advisory group, also includes the entire tile drain advisory group, and it includes the Lake Champlain Basin Technical Advisory Committee members that are working on the water quality or agricultural related information. And then one of the things that group will work on is the notification of tile drain installation. So what's the right information that we need, and what's the right methodology to get that? So that's something we'll work with to be available for fall in 2017. And then obviously continuing the research to get these technologies, to get these field practices, and to understand what's the right thing. But we'll get this group to figure out that overall 5-year research plan. And then one thing we don't have available right now is easements or incentives to, if someone doesn't want to tile drain a field or a farm, and they would instead like to move into other programs, there are wetland programs, but the incentives really aren't there to discourage tile installation if someone wanted that option and needed it to be viable. And so to create those programs and opportunities within the agencies. And some of them, you could do short-term agreements or you could do easements. The short-term agreements give you a lot more flexibility in working with doing additional conservation easements on the farm. So there's a reason to do that, not just because of short-term interest, but longer-term interest, actually. So this is the last slide. The next steps are there's discussion in the legislature. Obviously, this report was released. There was another bill that was proposed, and that discussion will be ongoing. We had proposed, originally Marli had mentioned that the REPs were supposed to be revised in 2018 to have the recommendations from this report put into it. Because of the time lag that it took in terms of the 2-year outreach that we did on the REPs and having all this discussion about tile, the Agency of Ag actually integrated several things already in the REPs about tile drainage. Like I mentioned, the inlet buffers, we'll integrate that into all of our inspections that we look at. And the 20 parts per million is a big one. Because again, if you don't, the source, managing nutrient management, managing the level of phosphorus in the fields, and measuring any direct conduits are the three major things that you could do to reduce the risk of tile. And again, that 590 nutrient management standard, the P index, is already part of the regulatory requirement, so it won't need a change. So with that, the agency said, we agree, we understand that there needs to be progress on this matter, but looking to have more concrete information as we go through this. So in 2022, to do that as the target goal of revising the REPs. Because if we were to revise them for 2018, we essentially would start now, and we just released that rule and haven't even had a field season to implement it. So to try and work towards implementing that. And then there's additional research projects that are planned to go on this year. So in St. Albans Bay, there will be sites that will be monitored for tile drainage and testing different conservation practices. And then an edge of field site up in the Missisquoi watershed on one farm doing similar comparison studies. And then there's a concept that UVM is going to work on developing an app for your phone to shut on and off a drainage control structure that we talked about, so over the winter. So that way you wouldn't have to physically go out there and lift those gates. So they'll start doing some technology benchtop work there. So again, we'll integrate tiles and NMPs. We're going to update those 590 requirements, and we're going to create that inventory process for the fall of 2017. Thank you. There's a link to where the final report can be found. And certainly, any questions anybody has, happy to try and answer.
Laura, can you go back to the concentrations you found in the right at the beginning, the range and cost, range?
You can use the arrows on here.
Is there a way to go back to the slideshow?
Yeah. That one?
Oh yeah, you had. Yeah, I guess so. So is there an explanation for why some fields, generate? Actually, I think it was the slide before where you gave the range.
Well, so yeah, let's talk about that for this one. So this Wilson site, which is much higher, as you can see across the board, has really high soil test phosphorus levels. Very, very little visible erosion. It's a pretty flat field, but really high soil test phosphorus levels. Really good management on that field. It's cover cropped, managed. The manure's injected. But again, I think sometimes that can outweigh if you've got this legacy issue. It's right behind the barn, and it's a very good field in terms of floodplain soils.
So would it make any sense to focus any kind of regulatory action on the worst offenders?
Well, so that's what. So the above 20 parts. So this is above 20 parts per million, for instance, and it's in a floodplain. So that's exactly that. And then if you look at these fields, these are steeper fields that have a lot of visible erosion. And so this is you remember this is the total dissolved. I think it's pretty. This is the total phosphorus. You can just see this field unravel. And cover cropping was the practice. This isn't the testing results. This is just the baseline information. But this field can have significant losses depending on rain events, essentially, because of the move. It takes enough to physically move the soil. So,
is there any logic to trying to sort out whether certain scenarios produce higher levels of phosphorus than other land use scenarios?
Well, and I think we've gotten there as far as we can. So, for instance, this particular field, there's a gully in that field. Actually, there's probably a couple of gullies, if I recall. Gully erosion is now not allowed. So, you've got to do something to this field to not meet that standard. So, those are the obvious ones.
Would it make sense to focus on just the tile drains, though? I understand why you have the edge of field monitoring, but
this isn't tile drain data. This is surface runoff data.
Okay, so what I was talking about was go to the. Do you have tile drain data?
No, we don't have tile drain data because these sites are only surface runoff sites. That's just it. We've not had any installation of surface and subsurface runoff sites in Vermont. There's one that was installed this year in New York. In Vermont, yeah. There's one that was installed in New York at Minor Institute, but it was such a dry year last year they really didn't have. And that's one of the challenges. Even for these sites that we set up, they're doing 5-year studies now. When you use the USDA funding for those studies, But the variability in year to year really does make it challenging, even 5 years, because you want at least 2 years to calibrate the site to know what it is before you do a conservation practice. And then if you've got one dry year, one wet year, you've got data that's, wait, what's the base information here that I'm then going to compare the change to? And so it is a challenge.
So why is there no monitoring of the pipes?
At that particular time, that's not what we were able to do. And one of the things, there was a site when we were searching for sites during this research phase that the farmer was interested in doing the tile versus the surface versus subsurface. It's incredibly challenging. The watershed that comes into a surface flume is not the same watershed that comes into the tile that may be right underneath that flume. And the reason is because that tile drain may do the whole field to where the watershed of the field may only be part of the field. And so you've got to map the tile drain. You've got to know exactly where it is. And many of these installations, people don't know. Their father or grandfather potentially installed it, and they generally know where it is, but they couldn't tell you where the watershed line is, right? And so it requires a detailed level of assessment. And we even tried to look at, okay, well, what if we came in and did some change to divert the tile, change it so that we know where the watershed is. And, I think in that estimate, it was like $10,000 just to make that one minor change as they were installing new tile in that instance so that we could monitor it. And the farmer, rightfully understandably just said, look, this just isn't, it was very complicated as far as the change in the tile installation. The maintenance on it and the concerns that they had were high enough that they said, I'm not really interested in that.
If I can follow up with you, because I think, Jim, your question is, why aren't we doing more tile sampling, to be honest? And there are a couple reasons for that. We had a lot of discussion about that with the work group and between the two agencies as whether that should be part of our recommendations. And one of the questions we came up with afterwards was, what do we do with this information once we get it, and how do we manage it? Because there's a big difference between the concentration of what comes out of a tile and the load that comes out of a tile. So you might take a sample and it's very, very high today, but if it only runs 1 day or 3 days out of the year, how much is it actually contributing of phosphorus? So the concentration might be very high, but if it only runs occasionally, it has less of an impact on the water quality. Also, if you sample it today and they spread manure yesterday, or if you sample a different site and they didn't spread manure yesterday, that has a difference in what comes out of the tile. Then you've also, of course, got the issue of how to access some of these sites. As Laura said, some of them are underwater, some of them are at the end of steep gullies. So there are a lot of challenges that go into sampling, because believe me, that was my first thought, was we just need to be sampling all these tiles, finding out where they're a problem, and then where they're high, we need to make the farmers do something different. Unfortunately, it's not that simple. So that's part of the decision that needs to be coming in the next couple of years, is how to do sampling so that we're getting the best answers out of it. And as far as sampling data goes, there has been some sample data going on, and as Laura mentioned, there's going to be some up in Jewett Brook this summer as part of a research project. But I can't begin to express the variability that we found among the tile sampling that has been done. There was a presentation up at the Friends of the Northern Lake meeting last week, and there were two researchers, one from Minor and one from Stone, who gave completely different data on the results of tile monitoring. And interestingly, the reason probably of the difference between the two was the soil test phosphorus. One of the fields had a very low level and one had a very high. That in itself could be the difference. So I think monitoring is critical. We've got to make sure that we use that data in the right way to make the best informed decisions. So.
Is there any estimate on the volume as well?
And again, that's a much more challenging thing to figure out. If you're going to be monitoring the tile, you better know what the flow is and what the watershed drainage area is, which is not always something simple to figure out. So,
I was just wondering, it seems like a crazy thought, but as a sugar maker, I mean, what if you were to pipe that tile drain effluent somewhere? Could you actually, you could obviously pipe it, you could obviously pump it, but not if the volume is just astronomical, like, stormwater surface runoff. But if the quantity isn't that high, why wouldn't you? Because it's a lost nutrient. Yeah, right? But you want to reuse it, essentially.
In a lot of cases, it's coming out of the pipe because it's not needed on the field. If the crop was taking it up, it would be.
Okay, but you could still pipe it and store it, possibly reuse it if it weren't such a huge quantity that it would be impossible to do that. Farmers have a lot of land, and you can make a lake that was sort of
In the Midwest, they do that. What's the EPA term? Irrigation backflow or whatever.
Return irrigation.
Return irrigation.
Yeah.
But again, I mean, if the field's saturated and that's why it's running off, that's the potential. But if it's submerged too, pumping, I mean, the maintenance and the challenge of these sites, it's an interesting idea, but where it applies to, again, and that's why learning more about what is out there will help us understand what design information do we need to build to essentially work. So maybe that only works in, not in the clay plains, but maybe just above them in the geographic landscape, maybe not up in the hills. So is there something geographically that it's more of an appropriate BMP to put in certain places? And that's where we don't know. I mean, the other thing that we want to look at, but again, we're going to talk with everyone about the research and goals, is just working in a ditch instead of working at the end of the tile. So if a tile has 5 lines coming into it over the course of the whole length of the ditch, if you did treatment systems, check dams, and did some of these dosing stations right in the ditch, would you actually have a better treatment effectiveness overall than not? So I think the challenge that we need to figure out is, we know, like I outlined, what we know, right? In good management, if the source is the issue, right? Where did it come from? Is it already in the soil, or did you apply it more recently? Managing those two things, regardless, is the most important thing, in my opinion, than what comes off, because that is what comes off, right? If you reduce that, you'll reduce what comes off. And so what investment is the most useful investment to move as fast as we possibly can towards a better solution? And so, reducing soil test phosphorus takes a lot of different alternatives, and researching what the number at the end of the tile is doesn't help you. You need to invest in something in the field, right, if you want to move faster. So trying to find that balance of how much monitoring do we do, what research areas do we need to focus, and what answers do people need to understand that where we're going is the right direction. That's what we're going to try and work on.
As a non-professional, just observer, I'm happy to hear the word fast coming from you, because we've been patient, I think, and watched our water quality in Vermont degrade because of phosphorus. And I'm very encouraged with some of the buffers and other things that are actually going to happen, I hope. But one thing I don't understand is the lack of knowledge where the tile drains are. If your agency subsidized the installation, that there's no paper trail of where our taxpayer dollars to help put them in were.
So
am I misunderstanding how it happened?
You're not misunderstanding,
Okay.
but I'll clarify. The state did not help.
The federal people.
The federal. And that is all protected privacy information that even the state government cannot access. The farmer themselves need to release information such as that.
But you're saying they don't know.
Well, those records as well. I mean, granted, they haven't done any of that since the 1980s.
Yeah.
So those records are on typewriters and paper files and probably archived somewhere, maybe in Fort Collins. I'm not even sure where they archive that stuff. So it's not readily accessible information.
But it seems more cost effective rather than have a machine and walk over every field in Vermont to find them.
Potentially, I mean,
they're inaccessible. We can't get permission.
Back then, I've actually seen some imagery. They hand drew what their best thought was. And so when you look at like Bing Maps or Google Maps today, you can generally see in the right time of year what that is, but that requires someone to go and actually physically map that. So that's some of the work that we're talking about. Do you get an intern to sit there and do line drawing so that we create this map layer to the best of our ability? Is that the better approach? And then in some areas where there's much more intensity or it was difficult to then pull out maybe ground penetrating radar to improve the mapping in those areas.
And I think that's part of the mapping that will occur. As Laura said, that's one of the recommendations that the agencies had, was to do this mapping. We're going to go back and look at what we can find for records. Obviously, we won't be able to get a whole lot out of NRCS directly from the past. But again, most of that was done so long ago that has been redone since then. Older clay tiles, many of which are beat up and cracked up. So there's been so much more put in since then. But mapping and figuring out where it is absolutely critical.
Well, I support that. I'm just surprised that data is not available, that someone's keeping it secret and not letting you have it to help solve the problems of our state. I'm just surprised at it because it's still all our government, whether it's state, federal.
It is, but there are federal regulations that forbid sharing of some private data on individuals' land.
Even if the farmer gives permission?
If the farmer gives permission, absolutely they can.
And they're saying no. Is that what I'm actually hearing?
We haven't gone to that level
Oh, you
to ask
haven't
the
asked
farmers,
them.
but again, I think that there's value in what Marli said. if it was 1970 something that was installed, and you'll see if you look at some of the imagery, you'll see where maybe it was installed in it looked like a tree, right? And now, 1995, they went through and did the systematic tile. So, getting that old data, while helpful and informational, I think we could get it faster, honestly.
So it's more effective to do it your way.
Well, we'll see. I mean, I think so. I think, again, there may be areas where it may make sense to go and try and get public permission for that stuff, if they're willing to. But as a broad blanket to try and do that, it's a massive Freedom of Information Act request to gather information that, again, is buried in vaults and paper files.
And one thing Laura didn't have a chance to talk about, what was in one of the slides, is DEC commissioned a literature review by Stone Environmental that was supplement to the other one she mentioned that asks, how do we find tile? Look into the research and tell us what's the best way to map tile. Is it by looking at aerial imagery? Is it the ground penetrating radar? There are smoke tests that you can do. So we do have a report from Stone that gives us recommendations on how to move forward. So we're going to be using that too.
What rules are there now regarding installation of tile drains, new ones? So if Fred Flintstone decides he wants to put tile drains in this field, what approvals does he need? And I would assume that if he does do that, that's very well documented. So everyone knows where it is and that sort of information. Do they need approval from the state in order to put a tile drain system in?
So tile drainage, again, is at the federal, state, national level. It is a allowed practice, so they can do it, just like they can implement any other conservation project.
What? Yes.
But what they cannot do, there are federal regulations backing that you cannot drain a wetland, and that, if you look at what tile drainage is best effective at, is draining wet areas. That is a big stopper for a lot of tile drainage installations going forward. I don't know when that passed, but that's been in place for a while. Most of the tile drain installs that you're seeing now are on lands that have been previously tile drained. So they're upgrading a lot of that. But again, that's where we want to get better data so we can share that information with everyone so that they understand sort of the demographics of tile drainage. But yeah, as long as you don't create a water quality violation of another federal rule like a wetlands or rivers, if you go through and mess up the bank of a river, navigable water issues, you are allowed to do it at this level. And that's where we're trying to figure out what's better guidance to give people and what are better practices, because it's the management on them that is really the driver in removing that source.
So the design of it and the installation of it doesn't have any state oversight.
Other than, again,
and also we don't have the ability to take an aerial photo while it's being done or anything else. In other words, to document what's being done to something that's going to discharge somewhere into a lake or a pond or eventually larger.
So exactly what you're bringing up is what we put in the recommendations, and that's what we're going to work with, is to create a notification process by 2017, the fall of this year. So exactly what you're saying is what we were talking about.
Is it mandatory or optional for the farmer?
We're going to figure out what's the right information we need and what's the right way to get it. So I don't know at this point, but that's our goal, is to try and figure out what is out there and available and what makes the most sense. What's usable data for research, for policy, all of those things. Did you have a question?
I was just curious if you're aware of what sensor technologies you're looking at that you could use with like drone flights to map. If that was maybe in the Stone report. I assume it probably is.
Yep.
It's expensive, but it's good.
We're also being a little cautious about using drones to fly around people's land and thinking that might be frowned upon. There might be some consequences.
And I think the other balance is too, I mean, how much money do you spend mapping? It could cost hundreds of thousands of dollars when in truth what you know is you've got already, in some watersheds, more than 70% of it is already drained. You need solutions, right? So that's where we've really got to figure out some of the science and innovation to work with that. The rate of new tile is nothing compared to what has already been put in place. So investing in understanding is important, but also the fast track really needs to be on solutions.
So unfortunately, I'm told we have to end this webinar because of the timing. Those of you who are here who would like to stay and ask some questions, I unfortunately have to leave, but Laura's staying. Anyone online, if you have additional questions and you haven't had a chance to ask them, please don't hesitate to email either Laura or myself with those questions. And apologize for cutting you off, but please send anything else to us as this moves forward. And watch each of our websites for updates as things go on. There, as Laura said, there's going to be a lot of discussion in the legislature on this, probably this year and next year. And we'll try and keep you folks abreast of what is going on. So thank you so much for joining us, and we encourage you to stay and contribute questions.
Just a couple other things. If you are in the room and haven't signed the sign-in sheet, if you could go ahead and do that. And then I also wanted to remind everyone of next month's brown bag on Rivers Project. Stacy Pomeroy from the Department of Environmental Conservation is going to be presenting that month's brown bag. So please join us either in the room or online for that, and I'll send out a notice by email as we get closer. And just thanks again to Laura and Marli, who quickly exited. She had another appointment. So thank you very much for talking today.
Thank you.
Everyone for joining us.
And the issue of the increase